Good morning and welcome to BremSter Puzzles, a channel where I try and showcase the fun that can be had in the world of variant Sudoku, and it's also educational as proven by this Sudoku U series of puzzles, which we're returning to today. This is a puzzle called Midbod by El Presidente and Silverlace, and the El Presidente and Silverlace were students in a class, which is a class that was run by FullDeck and Missing a Few Cards, and I believe it was their Puzzles and Paradoxes class. Designed to teach how logics and puzzles and different paradoxes can be used to solve different problems and different ways of logical thinking and how they are beneficial. I'm not trying to give a course guide here because I don't want to misrepresent the course, but it's teaching logical thinking is something that doesn't happen as much as it used to, and I'm really glad that this is a thing. But these puzzles were created as part of that classwork, and I've been lucky enough to be sent many puzzles that will be coming in an upcoming book, we hope, but you can get the puzzles through the channel. So the Sudoku U series of puzzles, there is a playlist of Sudoku U puzzles, yeah, here they are. So let's have a look at Midmod by El Presidente and Silverlace. So what do we have? We have normal Sudoku rules. So in every box, in every row, and in every column, we need to place the digits 1 to 9 without repetition. These teal lines are modular lines. And any set of 3 adjacent digits on a modular line has 3 different remainders when divided by 3. Kind of wish they would give the examples, but what that means is any 3 set of digits along the lines, you must have one. There are 3 different remainders if you divide a digit by 3. You can either have a remainder of 1, a remainder of 2, or a remainder of 0. The digits 1, 4, 7 out of the Sudoku digits have a remainder of 1. 2, 5, 8 have a remainder of 2, and 3, 6, 9 have a remainder of 0. You can figure that out by just dividing the number by 3 and seeing what the remainder is. The other way to remember it, which is the way I do it, is I use my numeric keypad. The vertical banding, because the numeric keypad is 3 across, 1, 4, 7 has a remainder 1, 2, 5, 8 has remainder 2, and 3, 6, 9 has remainder 0. If you don't have a numeric keypad on your keyboard, or if you're using a phone or something, the numeric keypad on Sudoku Pad helps because that is in the same banding. So from on any set of 3 lines must have 1 digit from 147, 1 from 258, 1 from 369. And it doesn't matter which section of 3 you grab along a line, that must be true for all of them. And then we've got cages, which is digits in cages cannot repeat. So these couldn't be the same digit no matter what the total was, and must sum to the value shown in the upper left corner of the cage. So we know these 3 digits sum to 18. Those 2 digits couldn't be the same. They're the rules. I'm going to restart the puzzle to restart my timer. Let's give this a shot. Now, the most obvious thing to me is this cage here. This is 3 digits that must sum to 6. So these must be 1, 2, 3. Because the minimum digits I could put in it are 1, 2, 3, and if you add 1, 2, 3, you get to 6. Now, this can't be a 3, because 3, if you divide it by 3, you get 0, and 9 divided by 3 is 3 3s with 0 remainder. This is part of the 3, 6, 9 set, and this is a 3 cell length long line. I can't, in this 3 section of 3 on this line, I can't have 2 remainder 0. So this can't be this. Where else do I want to look? These have to sum to 14. Actually, no, I want to start on this line because we know this is from the 1, 4, 7 set. So these 2 digits are going to be, I don't know which ones they are, but they're going to be from the 2, 5, 8 and the 3, 6, 9 set. So where do I put the digit from the 1, 4, 7 into this set of 3? Well, it's not in either of those 2 because in this 3, I've already got a 1, 4, 7. So this has to be a 4 or a 7, and the 7 looks across making that a 4. Now, these 2 are from the same set. I'm not sure which one it is. But these have to sum to 14 because this is a 15 cage minus 1. So if these are 14, they could be 9, 5. They can't be 8, 6. And they can't be 7, 7. These are 9, 5. But that doesn't break anywhere, I don't think. Okay. Oh, here's another 6 cage. This other 6 cage is the same, 1, 2, 3. Now, I can't make either of those 2 because This is a 3-length line, and I've already got a digit from the 258 set. So these are 1 and 3. That's a 2. The 2 looks like making this the 1, taking 1 out of both of those. This is from 147. This is from 369. This has to be from 258, and it can't be a 2 because 2 is already placed, and it can't be from 8 because 8 is already in the column. Okay, we're making some progress. The 1 looks down, making this the 3 and this the 1. We're making some more progress. Now, where do I want to look next? Possibly Sudoku. 9 and 9. 9 can't, well, the 9 is looking across, making that the 5 and that the 9, which means this, which is, okay, so this is from 147, this is from 369, so this has to be from 258, and it can't be from 5. So this is 2 or 8, because this can't be a 5 for multiple reasons. This digit now has to be from 369, because there is no 369 in that set of 3, but it can't be 3 and it can't be 9. That's a 6, which by Sudoku makes one of those two a 6, because of the 6s looking down. So if this was a 6, this would be a 7. That seems okay. It is going to be Sudoku. I need to do a lot more Sudoku. 9 and 9 puts 9 in one of those two. 9, 2 would make that a 4. I'm not seeing an obvious problem with that. 1 is in one of those two. These are from the same modular group, but I don't think that's what I'm looking at here. Minimum here. Well, this is a quadruple in the column. But these digits here, I've already got 6 of the 24. Those digits sum to 18. I can't use a 9. I kind of want an extra digit in this before I start playing with it. Maybe I'm being picky about that. Probably am. This is a 9. Why didn't I put... I thought I was just talking about that. 2 9s mean that these can't be 9s, and I had to put 9 here. I thought I started talking about that. I'm a little worried that I may be about to have a seizure, considering how off I seem to be with this. 9 and 9 puts 9 in one of those two. If that's 9, this would have to... Because this would be from the 369. These would be from the other sets. So this would have to be 369 to put the 369 in there. And that would have to be a 3, which would put a 3 there. And this would be 9, 3, which would be 12, and that would have to be 2. That does work. There's no 3, 6, or 9 in any of those. Yeah, I suffer from seizures, and I'm a little worried right now. 6 is down here. I think I'm missing something incredibly obvious. This is a 6-9 pair. 6-9, 6-9. This is a 6-9 pair. And that's potentially going to do it. Because I can tell what this is. This, well, this is from the 369 set, which is useful. So I know that those are not from the 369 set. And that can't be 2, 5, or 8, because it sees 5, 2, and 8. So this is from 147, and it can't be 1 or 4. That's a 7. 3 and 7 is 10, so that's the 6, and that's the 9. This is now not from 147 and 369. This is from 258, and it's not a 2. So this is a 5 or an 8. Okay, that's a thing. 1 in this box is in one of those two. I don't need a 369 on that. 369 could be there. This isn't from 147 or 258. This is from 369, and it's not 6 or 9. That's a 3. Which makes that a 3 by Sudoku, putting 3 in one of those two by Sudoku, because 3 can't be in any of those without breaking the 2-3 pair. 3 can't be in any of those. So we've got 9 and 3, so this is a 2-3 pair. So 2 is in one of those two now by Sudoku. Because 2 and 3 point, the 2-3 pair rules 2 out from those, 2-3 pair rules 2 out from those. This is a 5. 5 and 5 makes that 5. This is a triple. 1, 2, 3, 4, 2, 7, 8. These are 2, 7, and 8. 7 is in one of those two, which means 7 is in one of those two. If this is a 7, this would be 7, 2, 6. And I think it can be. Okay. But these are 1, 2, and 8. Oh, hang on. Where's 2 in this column? I can't put 2 down here. Yeah, this 2 means there's no 2 here. 2 is in one of those two, which means there's no 2 in any of those. That's the 7, 8. That's the 2. There you go. And that is a 7, 8 pair. This is a pair as well. 1, 2, 3, 4, 5, 6. This is an 8, 9 pair. If that's 2, so this is, if this is a 2, this is a 9. If this is a 3, this is an 8. But there's nothing here from the 1, 4, 7. So this has to be from 1, 4, 7, and it can't be 7. That's a 1 or a 4. That's interesting. But so this isn't from 1, 4, 7. This is either from 2, 5, 8, at which point it's 2 or 8, or it's from 3, 6, 9, at which point it's 3. This can only be 2, 3, or 8. I can possibly narrow that down further, but I'm not seeing it. These sum to 15. And I can't use a 9 in them. This is a 7, 8 pair. So these digits here can't repeat. And they sum to 18 minus 3, which is 15. I could have possibly started here. Maybe not. I needed that 9. So what could they be? Actually, no. I think I could have started here. Maybe not. These sum to 15. So if 15 in 2 is a high total. So how do I do it? Well, 9 plus 6, but I can't put 9 into either of them. 8 plus 7 could work. And the next option is 7 plus 8, and I'm repeating, so I can stop. So these must be 7, 8. And I don't actually see how to reveal that. I'm actually struggling with this one more than I think I should be. Four, 6, 7, 8 go in here. So I've got to put a 6 in one of those two. Could that be a 6? Four and 6 have to go in this. So this is a 7 or an 8, isn't it? That digit has to go in this box somewhere, and it goes there. That's a 7 or an 8. It is going to be this 24 cage, but I'm these three summing to 18, but I'd like more information about them. Like, I'd like something forced into it. These sum to 13. These are known. I've got 2, 3, 4, 5. These are 1 and 8. So this is a 5. And this, 1, 2, 3, this is a 4. So these are known. 1, 2, 3, 4, 5, 6. These are 7 and 8. So these are 2 and 4. So I do have something here. This sums to either 9, making that a 6, or 10, making that a 5. That is not the 9, that is the 9. And the 5 looks down, making that the 6. So if this can't be from 369. It's either from 147 or 258. If it's from 258, it has to be the 5. If it's from 147, it has to be 4 or 7. And the same here. Well, that 6 is saying that's not the 6, that's the 6. These are now only from 4, 7, 8. And there's no 8 there. But this has to be from, that one's way less restricted. But these are all from 4, 5, 7, aren't they? So 5 is in one of those two. So that's a 4 or a 7. This is a triple. 2, 5, 9. And 2 and 5 are from the same modular group. So there must be a 9 on there. I could have got that by Sudoku. Okay. So 9 is in here. Oh no, don't do that. I've already got the 9. Why am I so lost on this? Is it because I can't do this 24 in 4 in my head? Because I really find, like, this is 18 in 3. And there's a lot of options for 18 in 3. And I just can't wrap my head around those simply. So these are 4, 5, 7, and 8. And I don't in the column. And I'm not seeing any restriction on it. I could case this, but I'd prefer not to have to. 6 is in one of those two by Sudoku. I'm really lost on this one. 4, 5, 7. Could this be a 2 or a 3, I think is the question. Because I need to put a 2 or a 3 somewhere in this column. Yeah, I can't put 2, 3 down here. I can only put 1, 2, 3 up here. Could this be a 2 or a 3? Because if this was even a 3, these would sum to 9. Oh, I can actually. Those would sum to 15, and I could do that with 7, 8. I'm seriously stuck. And this was supposed to be an easy puzzle. I think my scanning's just a pot. This was sent through as one of the easiest puzzles in the entire series. So this is a triple. 1, I've got 2, 3, 4, 1, 4, 6. I've got almost no information about box 5, apart from these are not from 3, 6, 9. So 3 in this column is in one of those two. And 3 in this column is in one of those two. So I've got an X-wing on 3s. Because I can't put 3 here, that would break this line. I can't put 3 here, it would break this line. I'd have 2 from the 3, 6, 9 set. So we have an X-wing on 3s in those cells. So 3 can't go in any of those or any of those or any of those. That's a 3. That's crazy. I can't put 3 in any of those, because if I put 3 in any of those, where would I put 3 in this box? I'd have to put it on one of those lines or there, and I can't do it. So I can't put 3 in any of those cells. This 3 says I can't put 3 in any of those cells, and that 3 says I can't put 3 there. That's a 3, which means that can't be a 3, or I'd have 2 from the same set. That's a 2. That's a 3. This now has to be from the 3, 6, 9 set, making that the 9 and that the 8. That's really clever. That's brilliant. But I think that's quite tricky. The 2 looks down saying this isn't a 2. The 8 looks down making that the 7. 7 and 3 is 10, so that's the 8. So this is from 369 and 258. So these are both from 147, because this set of 3 doesn't have a 147 and that doesn't have a 147. That one isn't 7. That one isn't 1. The 9 looks down, making that the 5. So this can't be 2 or 5. That's the 9. This is the 2. This needs to be from, I've got 258 and 369. This is from the 147 set. So this is a 1-4, making a 1-4 pair, making that the 7, taking 7 out of those, which I could have done with that 7, but I got there eventually. So this row is missing a 1 or an 8. So where is the 1 in this row? It can't be in here because these are 1, 2, 3, 4, 5, 6, and 8. These are 6 and 8. The 6 makes that the 8, that the 6. The 8 looks back, making that the 1 and that the 8. There you go. That's very cool. That's really clever. I do like that, but this X-Wing on 3s, I think was tricky to spot. I'm still not sure how to resolve it. Maybe I did need to do more modulus coloring, but I don't know. So what are these? Well, this isn't the 6. This is the 6, which looks up saying this isn't the 6. This is the 6. So I've got 3, 6, 9 and 2, 5, 8. So this is from 147. This is also from 147 because I've got 3, 6, 9. Oh, no, it's not. This isn't from 147. 147, 3, 6, 9. This is a 2 by Sudoku. So this can't be from 258 or 3, 6, 9. This has to be from 147. And it's not 1 or 7. That's a 4. Taking 4 out of there. And taking 4 out of both of those. This 24 cage, I'm hoping will resolve it near the end. The 4 makes this the 5 and this the 4. So this is from 147. So that can't be the 1. That's the 1. This has to be now from 258 and it can't be 8. So this is only a 2 or a 5. And the 5 is looking down, making that the 2. Which looks up making that the 3, that the 2. Which makes that the 3 because of the 3 X-Wing. No. That the 3 by the 3 X-Wing. Man, I am really out of it. I am going to take some medication after this. This is from 5, 7, or 8, but this can't be from 2, 4, 7. This has to be a 5 or an 8. And something in this column, the 8 comes out of there. Something has to resolve it. The 5 makes that the 7, and this is a 5, 8 pair. The 8 makes that the 5 and that the 8. These are now going to do it for me. That's 9 plus 8, which is 17. To get to 24, I need another 7. So that's the 4, that's the 8, looking across, making that the 7 and that the 8. Cool. The 7 looks across, making that the 4, which makes that the 1, that the 4. The 1 looks up, making that the 7. The 4 looks up, making that the 1 and that the 4. Can I resolve this stuff? The 7 looks across, making that the 8 and that the 7. The 4 looks across, making that the 2 and that the 4. These digits are 1 and 5, and I'll use the 5 to make that the 1 and that the 5. And that is very cool. I don't know if there was another way apart from finding that X-Wing on 3s. That X-Wing on 3s was really clever. I really enjoyed it. I think I missed some stuff. I'm actually going to sign off and go have my medication. Thank you everyone for watching, and as always, good luck with your solving.